In this video, I'll discuss what quadratic form is, how to write an equation in quadratic form, and how to use quadratic form to solve an equation. First, the mathematical definition for quadratic form is that an expression is said to be in quadratic form if it can be written as a times u squared, where a is any constant, any number, and u is any expression, plus b is any number, times u plus c. This isn't as hard as it may seem. For example, 3x to the fourth plus 2x squared plus 1 is not a quadratic. It's not a polynomial where the highest power on the variable is a 2. However, it could be written in quadratic form if we could express it this way, where the a, which is 3 in this case, the b is 2, and then the constant is plus 1. Those stay the same. Can I write x to the fourth and x squared as the same expression u, first to the second power, and then to the first power? Well, x to the fourth is the same thing as x squared to the second power. And so that would be what I'm calling the u. And if I put that same u in the second term, where the coefficient is 2, I have 3 times x squared squared, which is exactly the same thing as x to the fourth, and then 2 times x squared to the first, which is what the original expression was written as, 2x squared. I've now taken 3x to the fourth plus 2x squared plus 1 and written it in quadratic form. It's not a quadratic, but I have written it as 3 times something to the second plus 2 times something to the first plus a constant. That's quadratic form. Another equation that can be written in quadratic form is 5x to the sixth minus 4x to the third plus 3. Again, what we'll have to do to write this in quadratic form is we'll say to ourselves, hey, could we write this as 5 times something to the second minus 4 times that same thing to the first plus 3? And what you want to think about is the fact that x to the second x to the sixth rather, is the same thing as x cubed squared. The laws of exponents say that when you have a power to a power, you would multiply these exponents, and 3 times 2 would be the 6. So x to the sixth is the same thing as x to the third squared. And so in this case, the u would be x to the third, and if I put that u in the second blank here and raise it to the first power, that is the same thing as x to the third. So 5x to the sixth minus 4x to the third plus 3, again, is not a quadratic, but in quadratic form, it can be written as 5x cubed squared minus 4x to the third to the first power plus 3. Now let's use quadratic form to solve an equation. X to the fourth plus 4x squared minus 12 equals 0 is an example of an equation in which quadratic form can be used to solve it. This is a fourth degree equation, so it will have 4 solutions. If I can take this fourth degree equation and write it in quadratic form, it will be fairly simple to solve. Remember, to write an equation in quadratic form, you have to be able to express it as something squared, some u squared, plus that same exact u to the first power. In this case, I'm starting with x to the fourth. So I'll think of what value squared is equal to x to the fourth. And it's true that x to the second squared is equal to x to the fourth. If I would multiply these exponents, 2 times 2 is 4. So if I can write this in quadratic form, the value for u would be x squared. If I write an x squared in the second term and raise it to the first power, I see that I do, in fact, get x to the second, which is what I need for the original equation. X to the second to the first is the same thing as the x to the second in the original equation. So replacing u with x to the second allows me to write the original equation in quadratic form. X to the fourth plus 4x squared minus 12 equals 0 is exactly the same thing as x squared squared plus 4x squared to the first minus 12 equals 0. This is in quadratic form, though, because I have some expression to the second plus another expression to the first. And if you have something in quadratic form, in the form of u squared plus, in this case, 4 times u minus 12 equals 0, you can solve this equation the same way that you would solve a quadratic equation. This quadratic equation can be solved by factoring. What I would do is I would write two binomials and begin each binomial with the term of u, and then think of two numbers that have a product of negative 12 and a sum of plus 4. Two numbers with a product of negative 12 and a sum of plus 4 would be positive 6 and negative 2. I can do that same thing with the original equation when it's written in quadratic form. What I'll do is I'll make two binomials, and instead of beginning the binomials with a u as the first term in each binomial, I'll begin each term with the value of u, which in this case was x squared. And then again, the two numbers that multiply together to be negative 12 and add up to be positive 4 are positive 6 and negative 2. And at this point, I have factored x to the fourth plus 4x squared minus 12. If you would multiply the left side of this equation out, you would get x to the fourth plus 4x squared minus 12. But now that it's factored, I can solve the equation by setting each factor equal to 0. Setting the x squared plus 6 equal to 0 and the x squared minus 12 equal to 0. If I set the x squared plus 6 equal to 0 and subtract 6 from both sides of the equation, this can be solved by taking the square root of both sides of the equation. Be sure to include a plus or minus in front of the square root of negative 6. Now, the solution here, the values of that x is equal to, are not real numbers. They can be written as imaginary numbers, positive or negative I times the square root of 6. But those are two solutions to the original equation, positive I root 6 and negative I root 6. You can find the other two solutions to the equation by setting the x squared minus 2 factor equal to 0, adding 2 to both sides of the equation, and then taking the square root of both sides, again including a plus or minus in front of the square root of 2. This time the two solutions for x are real numbers. They're irrational, but they are real numbers, positive and negative square root of 2. Now remember, our original equation was a fourth degree equation, which implies there should be 4 solutions, and we did find 4 solutions, positive and negative I times the square root of 6, and positive and negative square root of 2.